Hello and welcome back to Math with Mrs. Becker. Today in Algebra 2, we are going to solve linear systems using algebra techniques. Now in 3.1, what we did was solve those systems by graphing. And sometimes it wasn't necessarily the most accurate thing to try to find the location where those two lines crossed. So there is a more accurate way of finding our solutions. Those methods are called the method of substitution and the method of elimination. So we are going to go ahead and get right to it. Okay, it says the graph shows a system of linear equations, but as you can see, without the use of technology, determining the solution from this graph is not necessarily easy because it's not at an intersection. So you would be kind of guessing where that solution is. Rather than guessing, that's what I was talking about earlier, you can find the exact solution using one of these algebra techniques. The first one we're going to look at is substitution. If we are doing substitution, you have to solve one equation for one variable. What that means is you have to have either x equals or y equals for one of the equations. Then what you do is you substitute whatever that value is into the other equation. Let's go ahead and try it. So this is all set up for substitution. This tells me that y is really equal to x minus 1. So what I can do is I can take that information and go into the other equation. I have the x plus y. Instead of y, I'm going to put what y is equal to. X minus 1 equals 7. Notice everything except for the y stayed the same. The x stayed the same, the plus sign stayed the same, equals 7 stayed. Y became x minus 1 because that's what it's equal to. Now here I can combine like terms. 1x and 1x makes 2x minus 1 equals 7. Now I can solve. If I add 1 to each side, 7 plus 1 is 8. Divide both sides by 2 and x equals 4. But we're not done here, because what we're doing is the same idea as 3.1. We're saying if you graphed these two lines on a coordinate plane, where is the location where they would cross? Well, right now I only know the x. I know that I would have to travel to the right 4 units. To find out the y value, what I have to do is go ahead and substitute 4 in for x into the top equation. Y equals 4 minus 1. 4 minus 1 is 3. Now that I know x and I know y, I can write my final solution. Your final solution will be an ordered pair because, again, we're looking at a location on a graph. Where would these two lines cross? Let's look at another one. Let's use substitution. So substitution, y is really 2x minus 1. So I go to the other equation and I substitute that in for y. The 3x stays, the plus 2 stays, the equals 26 stays. The only thing that changes is y, and y changes to 2x minus 1. Now what I need to do is go ahead and simplify. So this is a multi-step equation where I only have x's. Step 1, when you're solving, you always want to simplify, meaning get rid of, get rid of parentheses and combine like terms. So I have 3x, 2 times 2x is 4x, 2 times negative 1 is negative 2, equals 26. Now I can combine like terms. 3x and 4x makes 7x minus 2 equals 26. Add 2 to each side, so 7x equals 28. Divide both sides by 7. 28 divided by 7 is 4. So I know what x is. Now what I need to do is find out what y is. So I take and I substitute 4 in for x in the equation that says y equals, because that's what I want to know now. What does y equal? Well, y equals 2 times x. X is a 4 minus 1. 2 times 4 is 8. 8 minus 1 is 7. So my solution is 4, 7. And what this means, if I graph these two equations on a coordinate plane, they would intersect at the point positive 4, positive 7. Okay, another one. Now this time, if you're using substitution, remember the rule states that you have to have one letter all by itself. If I look at how this is set up, that is not the case at all. So we need to isolate one variable. The easiest one to isolate here would be the x, because there's not a number in front of it. I can easily go ahead and minus 2y to the side. So I would have x equals negative 2y plus 4. These two things mean the same thing. I didn't change the value, I just moved something around. So I would no longer use this. This is what I would need, because substitution, you need to have a letter by itself. So now I know x is really a negative 2y plus 4. So I can go ahead and substitute that into the other equation. The 3 stays, I'm substituting something in for x, minus 4y stays equals 7. Instead of x, I substitute in negative 2y plus 4. Now I have a multi-step equation. Step 1, cancel the parentheses. 3 times negative 2y is negative 6y. 3 times positive 4 is 12, minus 4y equals 7. I can combine like terms. I have two y terms on the same side of the equation, so I combine them. Negative 6y and negative 4y makes negative 10y plus 12 equals 7. To solve for y, minus 12 to each side, negative 10y equals 7 minus 12 is negative 5. To solve for y, I would divide both sides by negative 10. Negative divided by a negative is a positive. 5 divided by 10 is 1/2. So now I know that y is really 1/2. I have to find x. X equals negative 2 times y. Y we just solved for, it's 1/2 plus 4. Negative 2 times 1/2, 1/2 of a negative 2 is negative 1. Negative 1 plus 4 is 3. So now that I know x and I know y, I can write my final solution. It is the ordered pair 3 and 1/2. Last one. Okay, if you are doing substitution, you have to have one variable that's all by itself. Now here I don't. This is pretty darn close. It's just a negative y. I can totally get rid of that negative as long as I divide every single thing in that equation by negative 1. Positive 2x divided by negative 1 would now change it to a negative 2x. Negative divided by a negative is now a positive. 2 divided by 1 is 2. Equals negative over a negative is a positive. So I will no longer use this. I am using the fact that y equals negative 2x plus 2. So now I can substitute that in to the other equation. So 5x plus 6 times, I'm substituting in for y, equals negative 9. Y is really negative 2x plus 2. Now what I need to do is solve for x. So it's a multi-step equation. Simplify. Step 1, cancel the parentheses. 5x, positive 6 times a negative 2x is negative 12x. Positive 6 times positive 2 is 12, equals negative 9. 5x minus 12x is negative 7x, plus 12 equals negative 9. To get rid of a plus 12, I minus 12 to each side. Negative 7 equals negative 9 minus 12 more is a negative 21. If I divide both sides by negative 7, negative divided by a negative is a positive. 21 divided by 7 is 3. So I know that x is 3. Now I need to find y. Well, y is negative 2 times x. X is a 3 plus 2. Negative 2 times 3 is negative 6 plus 2. Negative 6 plus 2 is negative 4. That's what y is equal to. Now that I know x and y, I can write my final solution. X is a positive 3, y is a negative 4. Now what I did here, your book assignment, they switch back and forth. They'll say do substitution, do elimination, okay? So the process that we just practiced, again, it's called substitution. And the directions in your book, in your textbook, for numbers 2 through 5 and 15 to 18, it will specifically say to use substitution. Okay, so you want to refer to those examples for number 2 through 5 and 15 to 18 when you're doing your assignment. All right, next, you can also solve systems of equation using what is called the elimination method. When you do elimination, what you want to do is be able to add the two equations together and completely eliminate one of the variables. The only way that that can happen is if you have opposite coefficients. Remember, a coefficient is a number that comes before a variable. So it's the number in front of a variable. So for example, if I have positive 5x and a negative 5x, if I go to add them, they would cancel out because their value would be a 0. So with elimination, your goal is to be able to add the two equations together and cancel a variable. Now this is ready for us because if I look in front of y, I have a positive 2 and a negative 2. They are opposite values. So if I add these two together right now, 3x plus 4x makes 7x. Positive 2y, negative 2y cancels, so it's not there. Equals positive 4 and a negative 18 is negative 14. To solve for x, I can go ahead and divide by 7. X equals negative divided by a positive is a negative. 14 divided by 7 is 2. So x is a negative 2. Now to solve for y, you go back to one of the original equations. It does not matter which one you select. You will get the same answer regardless, as long as you make all of your calculations correct. So if I'm going back to the top, 3 times x, x is a negative 2, plus 2 times y equals 4. Positive 3 times negative 2 is negative 6, plus 2y equals 4. If I add 6 over, 2y equals 10. Divide both sides by 2, 10 divided by 2 is 5. So now I know x and I know y. I can write my final answer, which is the ordered pair negative 2, 5. So that's what elimination is. Let's go ahead and practice a few more. This system is already set up for elimination. If I go ahead and add them the way that it's set up right now, I can see that the y's are going to cancel because this is positive 7y and negative 7y. So let's go ahead and add these. 4x plus a negative 12x is negative 8x. Positive 7y, negative 7y, they are eliminated. Negative 25 plus a positive 19, that's negative 6. So if I go ahead and solve for x, I divide both sides by a negative 8, so x equals negative divided by a negative is a positive. If I take 6 over 8, it's 3/4, or you could put 0.75, okay? Or you could go 3/4. Now what I need to do is find y. So I pick an equation. If I just pick the top, I go 4 times x. X is 3/4 plus 7y equals negative 25. Again, if you are more comfortable with decimals and you wanted to put 0.75, that's totally fine. Here, though, I kind of like this because I'm multiplying by a denominator. If you multiply by a denominator, it cancels. So I have 3 plus 7y equals negative 25. To solve for y, I minus 3. 7y equals negative 25 minus that 3 is a negative 28. Divide both sides by 7. Negative divided by a positive is a negative. 7 goes into 28 4 times. I know x, I know y, so I can write my final solution, 3/4 and negative 4. So that's another example of elimination. Okay, now this time, they will not all be set up for you. The previous two, we already had opposites. More often than not, you're going to have something like this. If I want to do elimination, I need to figure out how to make opposites. So let's say I want to cancel x. I can turn both a 3 and a 2 into a 6. But the deal is I need one of them to be negative and one of them to be positive. So if I multiply the whole top row by negative 2, this would become a negative 6. If I multiply the whole bottom row by 3, this would become a positive 6. When you multiply, you have to make sure that you multiply every single value, okay? Even on what's on the other side of the equal sign. So this becomes negative 2 times 3x is negative 6x. Negative 2 times positive 5y is negative 10y. Negative 2 times negative 16 is positive 32. Now the second equation, I am multiplying everything by 3. 3 times 2x is 6x. 3 times 3y is 9y. 3 times negative 9 is negative 27. Now I can add them together because if you look in front of the x's, I have a positive 6 and a negative 6. When you add those together, they become a 0. So the x's would be eliminated. Negative 10y plus 9y is negative 1y. 32 minus 27 is 5. To get y by itself, I need to divide both sides by negative 1. Positive divided by a negative is a negative. 5 divided by 1 is 5. So I know that y is negative 5. Now to find x, you go back to one of the original equations. I've been selecting the top, so this time I'll go ahead and select the bottom. 2 times x plus 3 times y. Y is really a negative 5 equals negative 9. I can take positive 3 times negative 5. Positive 3 times negative 5 is negative 15. Now I add 15 over. So 2x equals negative 9 plus 15 is 6. Go ahead and divide both sides by 2. 6 divided by 2 is 3. I know x, I know y. I can write my final answer. It would be 3, negative 5, written as an ordered pair. Okay, one more where we are looking at elimination. Okay, again, we don't have opposites, so you have to make your own opposites. Last time I canceled the x's, so this time I'm going to cancel y. If I look at in front of y, I have a 3 and a 5. Well, I can turn both 3 and 5 into 15. I need one positive and one negative. The cool thing here is the top is already negative, the bottom is already positive. So I don't have to change the signs. I just need to make both of these values the same, so I'm turning them into 15. In order to turn a 3 into a 15, I multiply by 5. In order to turn a 5 into 15, I multiply by 3. I need to make sure I multiply every single term by 5. 5 times 5x is 25x. Minus 5 times 3y is 15y. 5 times 42 is 210. Now I multiply every value in the second equation by 3. 3 times 8x is 24x. 3 times 5y is 15y. 3 times 28 is 84. Now I can add them together because look, my y's will be eliminated because in front of one I have a negative 15, in front of the other I have a positive 15. If I add 25x plus 24x is 49x. The y's are eliminated. That's why it's called the elimination method. 210 plus 84 is 294. To go ahead and solve for x, I need to divide both sides by 49. 294 divided by 49 is 6. Now to solve for y, go back and pick one of the original equations and change the x to a 6. So 8 times 6 plus 5y equals 28. 8 times 6 is 48 plus 5y equals 28. If I want to solve for y, I need to minus both sides, minus that 48 to both sides, leaving me a positive 5y equals 28 minus 48 is negative 20. Divide both sides by 5. Negative 20 divided by 5 is a negative 4. Once you know x and you know y, you can write your final solution, positive 6, negative 4. Again, the last few examples, they were a process called elimination. When you're going through your assignment, numbers 6 through 9 and 19 to 22 will specifically say use the elimination method. What that means is you need to take your equations and put them in a format where you can add them together and eliminate a variable. Let's keep on going. Okay, in lesson 3.1, we learned that some systems might end up actually being the same line, so you have an infinite amount of solutions. Sometimes you might graph a system and it doesn't have any solutions at all. They're parallel lines. Well, when we're solving using algebra, we might end up with those kind of scenarios. If you end up with what is called an identity, meaning all of the letters cancel and you have a number equals a number, like 0 equals 0, or 5 equals 5, or 8 equals 8. If you have something that is always true, that means that those lines are always touching, meaning they're the same line, so you have an infinite amount of solutions. If your variables both cross off and you have something that is not true, like 1 equals 3, well, when does 1 equal 3? Never. So what that means is you have lines that never touch, so they're parallel, so you have no solution. So it is possible to find infinite solutions as well as no solution when we are solving systems using algebra. Let's go ahead and try some of these. So it says classify. What that means is you're going to have either no solution or infinite, okay? They're not telling us to use substitution or elimination. Right away, I want to use substitution for this because I can see that I can easily get y by itself. I just need to minus that 3x over. So y equals negative 3x plus 1. If you have one equation where you have one variable by itself, use substitution. So now I can take 2, I'm going to substitute in y, plus 6x equals negative 18. Where y is, I'm filling in negative 3x plus 1. Distribute 2 times negative 3x is negative 6x. 2 times 1 is 2, plus 6x equals negative 18. When I go here and I combine the like terms, negative 6x, positive 6x, that's a 0. So I have 2 equals negative 18. So you ask yourself, all right, when does 2 equal negative 18? Never. So that means that these lines will never meet, so there is no solution. These are parallel lines. If you graphed those two things on a coordinate plane, you would have parallel lines. Let's keep on going. Okay, if you want to solve this system, again, they did not tell us substitution or elimination, so this time I'm going to use elimination. If I want to cancel y, this y has a positive 8, so I would need to have a negative 8. So I'm keeping the top the same, 56x plus 8y equals negative 32. Negative 8 times 7x is negative 56x. Negative 8 times positive y is negative 8y. Negative 8 times negative 4, negative times a negative is a positive. 8 times 4 is 32. If I add those together, this cancels, there's nothing left, so it's 0. This cancels, so it's 0. When does 0 equal 0? Always. That means that these two lines always touch, so they are actually the same line, sometimes called coinciding lines, and what that means is that you have an infinite amount of solutions. So that's all you'd have to put there for 3.2. When they say classify, you just need to tell me, are they parallel or are they the same? If they're parallel, it's no solution. If they're the same, it's infinite solutions. Okay, one more like this. Classify the system and determine the number of solutions. So if I want to use, let's go substitution again because I can easily get y by itself. So y equals, this is a positive 2x, so I would need to minus the 2x to the other side. Y is really negative 2x minus 6, so I substitute that in. 6x plus 3 times y, negative 2x minus 6 equals negative 12. Get rid of the parentheses, so 6x, 3 times negative 2x is negative 6x, 3 times negative 6 is negative 18, that equals a negative 12. Positive 6, negative 6 cancels. So what I have left is negative 18 equals a negative 12. So at this point, you know it's either parallel or the same. I know that because the letters canceled. When does negative 18 equal negative 12? Well, never. So that means that these lines will never touch. So they are parallel lines, which means that they have no solution. In your assignment, 10 through 13, this is where you are going to end up with your parallel or same line situations. Okay, so when you are on page 194, 10 to 13, don't be alarmed when the variables cancel. That is going to happen on those questions. What you need to do is ask yourself, okay, are these two lines parallel? They'll never be the same, they'll never touch, so there's no solution. Or do you get a true statement, meaning that those two lines always touch? It's the same line, so you have infinite. Now let's go ahead and look at a story problem. A veterinarian needs 60 pounds of dog food that is 15% protein. He will combine a beef mix that is 18% protein with a bacon mix that is 9% protein. How many pounds of each does he need to make the 15% protein mixture? Now, the reason why this is a system of equations, it's because we are looking at two totally different things. If I have X is beef and Y is bacon, the first thing we're looking at is that we need a total of 60 pounds. So the amount of beef plus the amount of bacon mix has to equal 60 pounds. That's the first equation because I need to take two kinds of dog food and add them together to get 60 pounds. The other thing that we're talking about, though, is protein. Remember in math, when you're dealing with percentages, you always have to make sure that you turn those percentages into a decimal. So if we're looking at beef mixture, the beef value is X. Beef is 18%. So 0.18X plus bacon is 9% protein, 0.09Y, we need 15% of the total. We know the total is 60. So I can take this 0.15 times 60, and this is actually 9. So here are my two equations. What I need to do is solve for X and Y. That represents the amount of pounds that you need for each. So if I want to go ahead and do substitution, if I get Y by itself, I would have Y equals negative X plus 60. So now I can go ahead in here and replace the Y. So 0.18X plus 0.09, Y is really negative X plus 60 equals 9. I can distribute. 0.18X, 0.09 times negative X is negative 0.09X. If I take 0.09 times 60, this is 5.4 equals 9. If I combine like terms here, 0.18X minus 0.9, it's positive 0.09X plus 5.4 equals 9. If I go to solve, I minus 5.4 to each side. So 0.09X equals 9 minus 5.4 is 3.6. Divide each side by 0.09, and X, which represents the amount of pounds of the beef mixture, 3.6 divided by 0.09 is 40 pounds. X is the beef mixture, so 40 pounds of the beef mix. To figure out how much of the other one we need, we go back to one of the originals. Well, here's the easiest one to deal with. If X is 40, what could you add to 40 to make 60? Well, that would be 20. So I would need 40 pounds of the beef mixture, and I would need 20 pounds of the bacon mixture for that animal to have 60 pounds of dog food that ends up with its dietary needs, which is 15% protein. So it's really cool what you can actually do with this stuff. I have one more example. I am a coffee nut. So the next example is all about coffee. A coffee blend contains Sumatra beans. They cost $5 per pound. And Kona beans, they're like the really good stuff. Kona beans are $13 per pound. If the blend costs $10 per pound, how much of each type of coffee is in 50 pounds of the blend? So again, we're looking at two different scenarios. I have X is Sumatra, Y is Kona. So I have Sumatra beans plus Kona beans, and we want 50 pounds. Okay, now it's the price. X is Sumatra. Sumatra, they're $5 per pound, plus Kona is $13 per pound. We are paying $10 per pound and buying 50 pounds. So our total is $10 times 50. So we are actually, this is wild, you guys, we're spending $500 on coffee. Money well spent. Now if I want to go ahead and solve for X and Y, the last example I did substitution, so this time I'm going to do elimination. If I want to cancel the X, this is like a 1X. To cancel 1X, I need to make it into a -5, so I multiply by -5. -5 times X is -5X. -5 times Y is -5Y. -5 times 50 is -250. If I add it to the other equation, notice I can do elimination because I have a -5x and a +5x. They're eliminated. -5y plus 13y is 8y. -250 plus 500 is +250. So if I go ahead and take 250 and I divide it by 8, I get 31.25 pounds. Y is Kona. So I would need 31.25 pounds of Kona beans. Now to find out X, I'm going to go to this one. So X plus 31.25 has to equal 50. So to solve for X, I just need to minus the 31.25 over. So 50 minus 31.25, I need 18.75 pounds. X is the amount of Sumatra beans. So folks, that's the kind of coffee you would want to buy if you want your blend to cost $10 per pound. Now in your assignment, 14 and 27 are story problems, so you can refer to the last two examples that we worked through to kind of assist you. There's my name, there we go. And this is what the assignment is for 3.2. I hope you guys had a great day today, and I'll talk to you soon.